Okay, so Year 11, let's have a look at T formula and how we use it. So we know, and Margaret does a pretty good introduction here about where T formula comes from, but let's do a quick rundown again and see if we can make sure we get our heads around what this all means. So solving some of these trigonometric equations when you've got sine theta, cos theta, tan theta, or different angles can get a little bit difficult. So let's see if we can write them in terms of a separate variable. So we'll just do a nice easy substitution, and that might take some of the heavy lifting out of the algebra. So let's start with, we'll let t, just a variable, equal tan theta on 2. Okay, well, tan theta on 2. Well, how will we deal with this? And why are we choosing this? Well, it'll become apparent in a little bit when we do a little bit of a manipulation. So, from one of our early formulas, we can see that tan 2 theta equals tan 2 tan theta on 1 minus tan squared theta. Well, let's just look at this and go, oh, all right. If I've got half an angle and I can put it into this equation, so let's look at how we do that. Well, this would mean that this one here could be also written as tan theta equals 2 tan half that, theta on 2, over 1 minus tan squared theta on 2. So that's why we chose half the angle, because it'll give us this whole angle in here. Yeah. So now we can just put t everywhere we see tan theta on 2. So tan theta equals 2t, whoops, I was going to put a square there, that was lucky, 2t on, oh, I've rubbed it all out now, I'll start again, 2t on 1 minus t squared. All right, well, that's pretty easy. But how does that help us with sine and cos? Well, let's draw ourselves a little triangle. And if this is theta, well, this is 2t, and this is 1 minus t squared. And this will become the square root. I might make that a bit bigger. The square root of 2t squared plus 1 minus t squared squared. Okay, keep our square root. That'll become 4t squared plus, and this is a perfect square, so that's the first thing squared, 1 minus 2 times 1 times t squared, so t squared, plus the last thing squared, which is t to the 4. I'll extend that a bit. And that equals, let's tidy this up, we'll put the t to the 4 at the front. Now I've got 4t minus 2t squared, so that's plus 2t squared. And then I've got plus 1. And very quickly you can recognise that that is a perfect square. That's the square root of t squared plus 1. And the square root of t squared plus 1, squared, is t squared plus 1, but we'll keep it in the same shape as what is written on the adjacent side to the angle, so we'll call it 1 plus t squared. Now that we know that, we can get sine theta. And remember, all this stems from t equaling tan theta on 2. Sine theta equals 2t on the hypotenuse. And the hypotenuse is 1 plus t squared. And cos theta equals the adjacent 1 minus t squared on 1 plus t squared. So now, look at this. This is where I get to now. And you get given these three equations on your formula sheet. Now, if I've got a trigonometric equation with an angle in it, and it's got sine and cos and tan, I can just say, well, I'll let sine, whatever the angle is, or cos, whatever the angle is, equal these things, which means I'll only have one variable to deal with. And then at the end, when I find theta, I can put it back into this substitution that I started with, this parametric representation, and I can solve it. Well, let's see how that would work. So here's a question I did in class. So let's have a look at this, and I'll do a couple here. Let's take the first one, and I did it in class today. So we've got 3 sine theta plus 4 cos theta equals 0. Okay, so this is a difficult thing to do, but I know that sine theta, what did we say that sine theta was? Well, sine theta was, or is, 2t on 1 plus t squared. So I'll just put it in, 2t on 1 plus t squared. And cos theta is 1 minus t squared. I'm going to put brackets on that because I've got a 4 there. All over 1 plus t squared. Well, this looks okay because I've got a common denominator. And I just remember, I should state, I'm going to let t equal tan theta on 2. That's my opening statement. And then I can put in those substitutions because I know if t equals tan theta on 2, I can represent sine theta as 2t on 1 plus t squared, and I can represent cos theta as 1 minus t squared on 1 plus t squared. So when I get t equals something at the end, I have to resubstitute in tan theta on 2. So this will give me 6t on 1 plus t squared. And over here, I'll get 4 minus 4t squared on 1 plus t squared equals 0. Common denominator, so that's easy. So I'll get minus 4t squared plus 6t plus 4 all over 1 plus t squared equals 0. Now I could multiply that 1 plus t squared across and get it equal to 0. I don't need to because I know that whenever I've got an equation that equals 0 and I've got a fraction, I just have to worry about the top. So negative 4t squared plus 6t plus 4 equals 0. Let's take everything over the other side. So I get a positive 4t squared, so 4t squared minus the 6t minus the 4. Let's get this down a little bit more manageable. So we'll divide everything by 2. So divide by 2, divide by 2, divide by 2, divide by 2. And that'll give us 0 equals 2t squared minus 3t minus 2. Okay, so let's do this split method, which we've done many times in class. So we'll get 2t squared. Now, 2 times 2 is negative 4. So I need something that multiplies out to negative 4 and adds up to 3. So that'll be negative 4t plus 1 t minus 2. Should be getting pretty good at doing the split method. And I'll get 0 equals 2. Let's factorise this bit here. Let's factorise this bit. And we'll take out 2t. And we'll be left with t minus 2 plus, oh, look at this, I get a 1 outside of t minus 2. Oh, that works out really well. 0 equals 2t plus the 1, and I get t minus 2. Oh, great. So this is really cool. So I can get t equals negative, oh, well, I'll do it just in case some people don't understand. I'll go, well, that means 2t plus 1 equals 0, or t minus 2 equals 0. Okay, so that means we'll just deal with this one. Minus a 1, 2t equals negative 1, divided by the 2, t equals negative a half. Over here I can go, oh, I'll just add the 2 over, so 2t equals 2. Almost there. What was my original statement? That to help me solve this, I was going to let t equal tan theta on 2. Well, I've substituted all that in. I've got an equation and a solution for t, so now I just put tan theta on 2. So that means tan theta on 2 equals negative a half. Well, that can be one solution. Or tan theta on 2 equals 2. Okay, well, let's deal with this. I'll inverse tan it. So theta on 2 will equal inverse tan of negative a half. Now straight away, I know that when I find the acute angle, when I inverse tan a half, when I find the acute angle, it's only going to exist in this quadrant because it's negative here. So I find the acute angle and I go 180 minus it. And in this one here, so I find the acute angle and I go 360 minus it, whatever the angle is. So let's just inverse tan this angle. And I'll just grab my calculator. So inverse tan, or in America, arctan. Now I could put in negative a half, or well, I will, negative 0.5. And it gives me negative 26, and that's okay because I know that on the tan curve, there it is, it looks like that. So the acute angle, the negative 26, will be the same as the acute angle here. So I know that theta on 2 equals, now remember, it's 180 minus the acute angle. So 180 minus 26 degrees, and I'll just get it in degrees, minutes, seconds. 26 degrees, 34 minutes. So 26 degrees, 34 minutes. But it also exists in that fourth quadrant, so it's 360 minus 26 degrees and 34 minutes. So I get my two answers. And I get 153 degrees, 26 minutes. And I get 360 minus 26 degrees, 34 minutes. And I get 360 333 degrees and 26 minutes. But hold on. That's theta on 2. So I have to multiply both these answers by 2. So if I multiply the first one, 153 degrees, 26 minutes, and it times that by 2, I get 306 degrees and 52 minutes. If I take this other one and I double it, 333 degrees, 26 minutes, and I times it by 2, well, that gives me 666 degrees and 52 minutes. And that's way out of the domain because look up here, theta has to be between 0 and 360. So we can ignore this one. It's out of the domain. And our first answer is 306 degrees and 52 minutes. Well, let's look at the second situation. Tan theta on 2 equals 2. Well, I again do the same thing. Theta on 2, I inverse tan 2. And theta on 2, now when I do that, so shift tan 2, and I get 63 degrees, 26 minutes. Well, that sounds pretty familiar. 63 degrees, 26 minutes. But I also know there's another one, because look over here, I get the acute angle, and I get 180 plus the acute angle, because it can be positive there as well. So I better put that one in, just in case. So 180 plus 63 degrees and 26 minutes. So I've got theta on 2 equals 63 degrees and 26 minutes. Plus, and I've got 243 degrees and 26 minutes. Now, I have to find theta, so I'm multiplying by 2. So 63 degrees and 26 minutes times 2. Well, that's okay. 126 degrees and 52 minutes. But 243 degrees and 26 minutes times 2 is 486 degrees and 52 minutes. And we have to ignore that one too because it's out of the domain, well out of the domain. So our two answers are 306 degrees and 52 minutes and 126 degrees and 52 minutes. Now that's a lot of work and it's quite difficult, but we are doing Extension 1 mathematics. I will do another one. I'm just going to check that answer. So 2A, yep, they're right. Let's have a look at another one. So I'm going to try C because I think C is going to be a little bit easier. So C, here it is. There it is. Sine theta minus root 3 cos theta. So here's C, sine theta minus root 3 cos theta equals 0. Well, I'm going to start off by saying let t equal theta on 2. Well, sine theta, what was that again? Luckily they give it to you. And here it is, 2t on 1 plus t squared. So 2t on 1 plus t squared minus root 3 times 1 minus t squared on 1 plus t squared equals 0. Well, that'll give me 2t minus root 3 minus minus, so a plus, root 3t squared. It's got a common denominator, we can just add it. 1 plus t squared. This is proving pretty easy. That's 0. Well, here's this equation. So again, I just take the top. So 2t minus root 3 plus root 3 t squared equals 0. Let's take it all over the other side. Oh no, we don't need to do that. So we get root 3 t squared plus 2t minus root 3 equals 0. Oh dear, what are we going to do here? Don't panic. Let's use our quadratic equation this time. So t equals negative b, so negative 2, plus or minus the square root. Oh, I'm going to get surds in surds. Don't worry. Watch this. B squared, 2 squared, minus 4a root 3 times c. Oh, negative root 3. Oh, beauty. The root 3's will go all over 2a. And that's 2 root 3. Okay. Negative 2 plus or minus 4 minus 4 times 3, 12, but it's minus, so plus 12. Oh, this is looking even better. Oh, I made a mistake there. I did something too quickly in my head because I saw what it was going to be. Over 2 root 3. So therefore, negative 2 plus or minus root 16 over 2 root 3. Negative 2 plus or minus 4 over 2 root 3. So let's look at these answers. Let's take the negative. So negative 2 minus 4 over 2 root 3. Well, that's negative 6 over 2 root 3. 2 will go into that 3 times. So I get negative 3 on root 3. Let's times by root 3 on root 3 to get rid of the surd underneath. And that'll give me negative 3 root 3 on 3. Oh, look at this. Beautiful. The 3's cancel. So t equals negative root 3. Let's take the positive side, which will be negative 2 plus 4 on 2 root 3. Well, that'll be 2, by the way, on 2 root 3. The 2's will cancel, which leaves me with 1 on root 3. Great. So now I've got 2 nice answers. Now, what was my original statement? Way up here, saying that t equals theta on 2. Well, let's come back down here and we'll say, okay, let's take the first option. Tan theta on 2 equals negative root 3. Well, straight away, I'm going to find the acute angle and see if we're going to be 180 minus the acute angle, so it's not negative there, or 360 minus. And I've got a sneaking suspicion now that when I find that one in the fourth quadrant, I'm going to have to double it. It's going to be outside my domain. But we'll do it anyway and we'll see what happens. So I don't even need to go to my calculator now because I know when I find an angle here that, what am I doing? I'm getting too excited because I can see the solution. 60, 30, 1, 2, root 3. So it's going to be 60. The acute angle is 60. So theta on 2 will be 180 minus 60, and 360 minus 60, which will give me 120 or 300. But that's theta on 2. So theta will equal 240 or 600. And we can ignore 600 because it's outside the domain. And we just get our first answer of theta equals 240. And we look at that, and yep, that's one of the solutions. Let's have a look at the other solution. Tan theta on 2 equals 1 on root 3. Well, I've already drawn the triangle. Look at this. We know that it's going to be 30. So the acute angle is 30, and it's going to be here and 180 plus 30. So here we go. Theta on 2 will equal 30, and 180 plus 30. So theta on 2 will equal 30 or 210. Let's double both of those. So theta will equal 60 or 420. Well, we can ignore that one. It's outside the domain. But we will keep this one because it's inside the domain. And we look up and we see that the answer is 60. And that is brilliant. So C was a lot easier because it popped out nice and neatly. A was a little bit more difficult, but only because we had to inverse tan and get the answer in degrees, minutes, and seconds. And I know that some of you would have found finding that acute angle quite difficult. Anyway, that's A and C. You have a go at E, G, I on your own. They're hard and they take a bit of time, but you need to practice them. Okay, good luck.